Vulkan's uphill battle against CUDA dominance. The dream of a universal GPU computing API has long tantalized developers tired of vendor lock-in, but as a detailed Reddit discussion reveals, Vulkan faces formidable obstacles in displacing CUDA for machine learning workloads. The original poster, new to GPU programming, noted promising developments, Vulkan matching or even beating CUDA performance in projects like llama.cpp and the new cooperative vectors feature enabling maximum hardware utilization. Yet the reality is far more complicated. One commenter laid out the landscape starkly. CUDA dominates with a heavily optimized ecosystem including libraries like QBLAS and QDNN, plus excellent tooling like Nsight Compute. AMD's ROCm, while miles better than it used to be, still struggles on consumer hardware, and Intel's Cycle remains largely Linux-only with spotty Windows support. A critical technical distinction emerged from an adaptive CPP developer. Vulkan is entirely a different beast and does not occupy the same niche as either Cycle or CUDA. CUDA and Cycle are single-source models. Vulkan is separate source with some shader-derived limitations that feel like Stone Age compared to modern GPU compute programming models. The rapid evolution of AI data types and specialized instructions makes it challenging for any standard to keep pace. Just because Khronos defines matrix computation extensions doesn't mean vendors will implement them efficiently or at all. The operator support problem looms large. Handling 8-bit values, integer versus floating point operations at low bit widths, sparsity support, and sub-8-bit values all present unresolved questions. As one commenter noted, NVIDIA Vulkan isn't the same as AMD Vulkan for recent features, in practice, if not theory. NVIDIA's approach creates what one poster called a carrot-and-stick dynamic. The carrot is CUDA's simplicity and efficiency. The stick is NVIDIA's refusal to publicly disclose low-level GPU ISA, instruction set architecture, and prohibition on reverse engineering. This architectural secrecy will never allow Vulkan developers to reach CUDA level of optimization, though others questioned whether this matters practically since NVIDIA engineers do work on Vulkan for llama.cpp. AMD, by contrast, open sources its ISA at gpuopen.com, though one commenter suggested this was a bit of sleight of hand, essentially telling the community to handle issues themselves. The non-technical barriers are equally significant: wrong perceptions that Cycle is Intel's CUDA, outdated training materials, and fear that alternative projects might disappear. For now, Vulkan remains viable for basic inference and shows promise at matching CUDA performance in specific projects, but the dream of a truly universal ML computing API remains elusive. Semantic compression sparks skepticism and interest. A new open-source project called Dragon Memory claims to achieve 16 times semantic compression for local RAG, retrieval augmented generation contexts, but the community response has been mixed. The project compresses token embeddings along the sequence dimension. 16 token embeddings become one latent vector, while attempting to preserve sentence-level meaning through learned reconstruction. According to the developer, semantic reconstruction achieves approximately 0.90 cosine similarity on Wikitext 2 and 0.85.89 on technical and literary texts, with self-recall at 1 reaching 1.0 across datasets. The skepticism surfaced quickly. One commenter pointed to a harmonic signature protocol notation in the README, complete with mysterious parameters like omega 6.3 as evidence of vibe-coded LLM documented work. More substantively, critics noted that taking 128 tokens and compressing them into a 3072-dimensional vector actually takes more space than the original tokens, and that any recent embedding model with Matryoshka support would have compressed that smaller and likely better. The developer clarified that the compression operates on the sequence of embeddings rather than raw tokens. 128 384, 8 384, so I store 16 times fewer positions per chunk. The resulting 3072-dimensional vector comes from flattening 8 times 384 for RAG retrieval. Whether this approach offers genuine advantages over existing techniques like Matryoshka embeddings remains to be seen. The developer acknowledged willingness to add comparative baselines and update the README accordingly. Agent debugging tools seek community validation. The proliferation of AI agent frameworks has created a new problem. debugging autonomous systems that make chains of decisions. Two projects announced this week attempt to address visibility into agent reasoning, though both face the perennial challenge of standing out in a crowded, hype-saturated space. Memento, described as a lightweight visualizer that turns raw agent traces into a clean, understandable reasoning map, seeks early testers among developers frustrated by missing visibility, weird loops, or unclear chain of thought. The developer emphasizes the tool is local first and operates entirely in browser, parsing JSON traces and rendering graphs without uploading or executing anything remotely. Community response was tepid. One poster bluntly noted, "This is our local llama," while another expressed fatigue. Every day, several novel agents, frameworks, whatever appear. Half of them are not even open source and are just cross-posts to every AI Reddit out there. Most of them are vibe-coded by wannabes. A similar project called Sybil positions itself as an open-source orchestration layer for LLM workflows, treating workflows as configuration files that define providers, shops, agents, RAG, data generation, and techniques. The architecture emphasizes separation of domain logic from runtime and plugins, aiming to be more something on a core spine you can attach to other tools rather than an entire ecosystem. Meanwhile, a Claude Agent dashboard seeks feedback on whether a visual dashboard for creating and deploying Claude Code subagents as scheduled jobs would be useful beyond current Claude Code capabilities. The pattern across all three projects is similar. Developers building solutions to real pain points in agent development, but struggling to differentiate themselves and prove value in a market saturated with half-baked offerings. Fine-tuned models face off on structured output. A production benchmark comparing self-hosted Qwen30B with LoRa fine-tuning against Llama 3.18b and GPT 4.1 Nano yielded surprising results that challenge assumptions about model size and quality. The task involved rewriting generic LeetCode problems into complex JSON-structured engineering scenarios with constraints, roles, and company context, with Claude Sonnet 4 serving as the teacher baseline at 0.795 quality score. The developer expected the 30B parameter Qwen3 coder model running on 2-tine H100s to dominate. It didn't. Qwen3 coder 30B achieved only 0.71 1.0 quality score, struggling particularly with negative constraints like do not add new function arguments and hallucinating keys outside the target schema. Llama 3.18b fared worse at 0.68, with parsing failures approximately 24% of the time. The model apparently suffered from catastrophic forgetting regarding strict JSON syntax, frequently missing closing brackets or nested structures. The winner was GPT 4.1 Nano at 0.784 quality score, 96% of teacher fidelity, handling the schema with 92.3% parsing success at only $0.30 per thousand requests versus $5.50 for the self-hosted Qwen setup. Community suggestions focused on model selection, trying the Qwen3A3B 2507 thinking or instruct variants rather than the coder model, or the dense Qwen32B, which is considered better than 30B. One commenter suspected the MoE mixture of experts, sparsity in the 30B model was exactly why my previous run choked on negative constraints. The benchmark highlights that for structured output tasks, instruction adherence may matter more than raw parameter count. Blackwell GPU support gaps frustrate early adopters. Users of NVIDIA's newest Blackwell architecture GPUs are encountering frustrating compatibility issues with Llama, the popular local LLM serving tool. One user with an RTX 5070 Ti reported that despite a fully functional GPU, NVIDIA SMI works, other services successfully use the GPU, Llama immediately falls back to CPU-only mode. All local models show 0 VRAM allocation, and simple queries take 60+ seconds. The system worked before November 17, 2025, with logs from that date showing successful CUDA backend loading, but after a reboot the following day, GPU detection stopped entirely. The hypothesis centers on compute capability. The RTX 5070 Ti features compute capability 12.0, which may not be supported by Llama 0.2.11's bundled CUDA runners. When initialization fails, Llama gracefully falls back to CPU without error messages, making diagnosis difficult. Community suggestions included upgrading CUDA from the really old version 12.2 to v13, verifying use of the 580 open driver required for Blackwell, and trying environment variables like CUDA force PTX JIX1 to force JIT compilation for newer architectures. Others noted success running RTX Pro 6000 Blackwell cards with llama.cpp and ikllama.cpp directly, which are significantly faster than Ollama anyway. Another user with a laptop RTX 5070 Ti confirmed experiencing the same issue. The situation illustrates the ongoing friction between rapidly advancing hardware and the open-source inference ecosystem's ability to keep pace. Even NVIDIA itself is reportedly struggling on Blackwell hardware. AI-assisted documentation and code quality tools emerge. Two new open-source projects aim to help developers generate better documentation and maintain code quality through AI assistance. Davia, announced as a framework for letting coding agents generate interactive documentation, addresses a frustration familiar to anyone working with AI coding assistants. The models understand code structure but don't represent it in easily explorable or shareable formats. The tool enables agents to visualize code flows, dependencies, and structure as interactive, editable documentation. On the code quality front, a comprehensive push repo code quality audit system has been shared as a detailed prompt framework for reviewing Git changes before pushing. The system enforces a fail-fast philosophy, systematically identifying mock code in production paths, placeholder implementations, silent failure patterns, fallback logic without failure signals, workarounds, incomplete error propagation, and insufficient logging. Issues are classified by severity: critical, high, medium, low, with specific remediation guidance. For clean code, the system automatically stages, commits, and offers to push. For issues, it presents interactive options to fix with AI assistance, commit with tracking tickets, or cancel entirely. The 635-line document exemplifies how structured prompts can enforce engineering best practices through AI-assisted review processes. Security consciousness grows in agentic and container domains. As AI agents gain autonomy to read, reason, and act on behalf of users, security researchers are increasingly concerned about novel attack surfaces. A LinkedIn post summarizing Hacker News discussions noted that the moment you have agents that read, reason, and act, you also create openings for instructions that don't look malicious on the surface but trigger dangerous behavior through a chain of delegated decisions. The attack pattern is subtle. Rather than targeting the main agent, attackers can target weaker sub-agents, plant context in harmless-looking fields, and let the system connect the dots. The author emphasized designing for traceability, isolation, and controlled memory, assuming exploits exist before anyone finds them. Container security received attention through Docker Shield, a new open-source tool that scans for exposed ports before hackers do. The motivation is practical. Docker bypasses UFW firewall rules by default by directly manipulating IP tables, meaning standard firewall configuration won't protect containerized databases. The author learned this the hard way when receiving a VPS provider alert about suspicious activity on port FIB432. Their production PostgreSQL had been exposed for 3 months despite UFW configuration. The tool scans for 50-plus dangerous ports, maps Docker networks, detects when Docker bypasses UFW IP tables, analyzes SSH security, and checks fail-to-ban status. A companion project, Container Diet, uses OpenAI's GPT-4o to analyze Docker images and Docker files, providing sassy but helpful optimization advice covering image size reduction, security improvements, and best practices. Section: Desktop Customization and Hardware Optimization Deep Dives. For Linux enthusiasts seeking precise control over their computing environment, 2 detailed technical articles offer deep dives into customization and optimization. A comprehensive guide to the Qtile window manager, written entirely in Python, documents months of configuration refinement. The author emphasizes Qtile's unique advantage. Having your window manager configuration in Python means you can write complex logic for hardware detection, create reusable functions and modules, integrate with system tools seamlessly, and debug configuration issues using Python tools. Highlights include smart mouse movement between monitors that calculate screen center positions, hardware-aware widgets that automatically detect battery presence and network status, and AMD GPU monitoring integration using AMD GPU SMI for real-time VRAM usage in the status bar. In the realm of precision timekeeping, a Raspberry Pi NTP server project achieved an 81% reduction in frequency variability through CPU core pinning and thermal stabilization. The root cause of timing drift wasn't GPS signal issues, but thermal sensitivity of the crystal oscillator. As the CPU heats and cools throughout the day, so does the nearby 19.2 MHz oscillator, shifting frequency by parts per million. The solution dedicates CPU 0 exclusively to Cronid and PPS interrupts while running a PID-controlled time burner on CPUs 1 to 3 that maintains constant 54 degrees Celsius temperature through controlled busy loop operations. The author notes these techniques solve problems that 99.999% of people and 99% of data centers don't have, but for precision timing applications, the improvements are dramatic. Microsoft opens Zork source, smallest ESP32 Amazes. In a celebration of computing history, Microsoft has open-sourced the original Zork Y, 2, and 3 under the MIT license. Working with digital archivist Jason Scott of Internet Archive fame, Microsoft's open-source programs office, Team Xbox, and Activision submitted pull requests to historical source repositories adding clear licensing and documentation. The release includes source code, accompanying documentation, build notes, and comments. When Zork arrived, it didn't just ask players to win, it asked them to imagine, using only words on a screen to build worlds more vivid than most contemporary games. The underlying Z-Machine virtual machine was quietly revolutionary, enabling the first truly cross-platform games by interpreting the same story files on Apple IIs, IBM PCs, and more. The games remain commercially available on Good Old Games or can be compiled locally using ZILF, the modern Z-Machine interpreter. On the hardware miniaturization front, the F32 claims to be the smallest ESP32 development board yet seen, measuring just 9.85 mm x 8.45 mm, barely larger than its USB-C socket. The trade-off for this extreme miniaturization is stark. Only one GPIO pin is broken out, and it's pre-wired to an LED. To achieve this footprint, creator Pegork used 0105 resistors at 0.4 mm x 0.2 mm, as minuscule as you'll find. The size code could be read as, "Oh God, too small," and the creator admits to hand soldering these components, using a hot plate only for the final step. Antenna matching circuits and decoupling capacitors had to be cut to fit, so this board is more of a stunt than anything practical. But for those seeking an excuse to work with truly tiny components, it delivers. Research advances in distillation and inference efficiency. A new research paper introduces ORPO Distill, a method for cross-architecture LLM distillation that reformulates knowledge transfer as a preference optimization task. Unlike standard chain-of-thought distillation that relies on single reasoning traces, ORPO Distill transfers knowledge through diverse reasoning traces and employs an odds ratio preference optimization objective that contrasts teacher-generated positive traces against student-generated negative traces. The key insight is that utilizing negative traces from student-generated outputs yields better contrastive training results than using teacher traces for both positive and negative examples. A mixed policy update strategy, combining traces from both the initial student model and the latest training checkpoint, outperforms purely off-policy, fixed negative set, or on-policy, new negatives every epoch approaches. Purely on-policy updates actually degrade performance because, although recently sampled negative traces are of higher quality and closely resemble correct rationales, the overall distribution narrows, reducing diversity for contrastive learning. On the inference efficiency front, a Hugging Face blog post provides an excellent first principles explanation of continuous batching, the technique that maximizes LLM serving throughput by processing multiple conversations in parallel and efficiently swapping completed ones for new requests. The post builds from attention mechanism fundamentals through KV caching, which reduces per-token compute from ON to O1 by avoiding recomputation, chunked prefill, processing long prompts in memory-constrained chunks, static batching, simple but wasteful due to padding, and dynamic batching, better but still padding heavy. The core innovation of continuous batching is eliminating the batch axis entirely. Prompts are concatenated rather than batched, with attention masks creating block diagonal structures that prevent cross-contamination between different prompts tokens. This enables mixing prefill and decode operations, processing prompts of different lengths without padding, and maximizing GPU utilization. Section New Models push OCR and reasoning frontiers. Allen AI has released OMO3, a new family of open language models including 7B and 32B variants in both instruct and think configurations. The think variants feature long chain-of-thought reasoning that improves performance on math and coding tasks. The 32B think model achieves impressive benchmark results, 96.1% on math, 76.8% on 2024, 72.5% on 2025, and 83.5% on Live Code Bench v3. The training pipeline involves 3 stages: supervised fine-tuning on the Dolce Think SFT dataset, direct preference optimization on Dolce Think DPO, and reinforcement learning from verifiable rewards RLVR on Dolce Think RL. All code, checkpoints, and training details are being released openly, continuing AI2's commitment to enabling the science of language models. Tencent has released Hunyuan OCR, a 1B parameter end-to-end OCR expert VLM vision language model that has achieved multiple state-of-the-art benchmarks. Despite its remarkably lightweight design, the model demonstrates mastery in complex multilingual document parsing and practical applications including text spotting, open field information extraction, video subtitle extraction, and photo translation. Application-oriented prompts enable different task modes, detecting and recognizing text with coordinate output, parsing formulas to LaTeX, converting tables to HTML, rendering flowcharts as mermaid diagrams, and extracting structured information as JSON. The model supports both transformers and VLLM inference backends. Meanwhile, a new LoRa fine-tune for Qwen image edit called InScene enhances scene-based image generation, trained on pairs of different shots within the same scene to create entirely new shots within a scene while maintaining character consistency and scene coherence. On-device computer use arrives with privacy focus. Microsoft has released Farah 7B, an on-device AI computer use agent that operates by seeing your screen and performing actions like clicking, typing, and filling forms. Unlike cloud-based solutions, the model runs entirely locally, quantized to just 8.1 gigabits, smaller than most AAA games, more useful than most Jira tickets, as one enthusiastic post put it. The MIT licensed model offers best-in-class computer use accuracy while keeping sensitive data on the user's machine with no cloud API calls or keystroke logging. The emphasis on local operation addresses a key concern about AI agents. AI in the cloud is not aligned with you, it's aligned with the company that owns it. The release represents a significant step toward practical local automation that respects privacy constraints. For enterprise environments, the model could automate "please don't GDPR violate this" tasks, workflows involving sensitive data that cannot be exposed to third-party cloud services. The local-first approach also eliminates concerns about service reliability, API costs, and latency. As computer use models mature, the question of whether automation should happen locally or in the cloud becomes increasingly important for both individual privacy and organizational compliance. Microsoft's decision to release this capability as an open, locally runnable model rather than a cloud service signals recognition that some use cases fundamentally require on-device processing.